Hi. The other day we did a lab using RIP version 2, and that's a vector-based routing protocol that basically just skip or counts the hops and figure out which way is the shortest path, the least number of hops. And so today we're going to expand our view into EIGRP. We're skipping IGRP because it's the same basic setup, but there's some drawbacks that were figured out by or enhanced by EIGRP, in other words, enhanced IGRP. So the commands are basically the same. We're going to add a couple show IP protocols. We're still going to do show IP route. We'll look at it a little differently. Show IP EIGRP neighbors and show EIGRP topology, if I remember to do them. And we're not going to talk about it too much as we go through. We're just going to do the implementation. It's up to you basically to do the reading, and you can search this on the internet and read all about it easily. There's a process ID, and you'll see I'm going to put in the command router EIGRP 100. I think it can go all the way up to a 32-bit number now. It used to be a 16-bit number. And they call it an autonomous number, autonomous system number. But basically, when you research autonomous system, those are used out on the internet by ISPs. We're not going to use an AS number on the inside, but what they are is a process ID. And what they do is allow you to group up your routers using EIGRP into different groups. They'll talk to each other, and unless you tell them to, they're not going to talk to the other groups. Same with RIP. We're going to have to redistribute our static route. We're only going to use one static route. That'll be on our NAT router, and the rest of the router should be able to figure out a way out once they converge. Now, the difference in convergence, we should see a huge difference in convergence. When we broke a line in our RIP experiment, it took quite a while. I don't know, maybe 90 seconds. That's a long time in computing time, right? 90 seconds. But with EIGRP, we should see a significant difference in the convergence time when we break our route by getting rid of a serial line or something like that. So EIGRP a little bit different. When we put in our networks for RIP, we put in just plain subnet IDs, and you look at the first two bits to figure out if it's class A, B, or C. But now with EIGRP, we're able to use variable length subnet masking. We're going to do the same thing as we did with RIP. We're going to make a passive ID on our IPNet outside, because we don't want to advertise our networks out to the outer world. All right. Now there's two different ways of entering the subnet, and sometimes it's dependent on the router. But we should be able to put. I tried them both ways on our 3640. This is the subnet mask method that you're probably familiar with already. So this is a class C subnet, and it's going to have a whole octet of hosts, or 256 hosts, with the subnet ID being one of them, the broadcast ID being the other. So there's 254 available hosts in this network. Same with these, and then this one is like our access list. We use the I lost the word. We're going to use wildcards rather than, and it's like the opposite or the inverse of the subnet ID using a subnet mask. What we're going to do here is say, well, what we're going to do is use the last 3 bits. So this subnet is actually the 252, and the last 3 bits are hosts. So it's a little bit different, but it should enter either way. All right. Now This is what I'm going to put into my router configurations. I should be able to just copy and paste this right in, right? I'll only need to redistribute static in the first router. So I'm going to copy this and go down to router A. Let's see. We're going to leave that one static route in there. There's my access list. There's my IP NAT inside. Source list 1 overload, so that's turning NAT on. And let's see. I'm going to get rid of this router RIP. And Control V. So basically I have the same thing in there, except for it's set up for EIGRP. My interfaces should all be the same. I'm not going to change any of the interfaces, right? Let's go back up here and recapture this without the passive interface. I don't want to have a passive interface on any more of my routers, right? I only want that one on the outside of the NAT box. So let's go down to router B. Let's see, here's router B. So Control V, see if I did it right. Yep, I've got my router EIGRP, process ID of 100, and those are arbitrary. So I get down to here and it should easily jump right into the interfaces, and I'm going to have all the same interfaces. My serial lines, I put clock rates on both sides of the serial lines. Again, you don't need a clock rate on the GNS3. Oh, this doesn't seem to be too difficult. Hopefully it'll take them. Down here, router F, router D, and the router will tell me if I'm going to have an error. Router E, and that's it. Alright, I've already got GNS3 running here, and I've already got my resource monitor running over there. So let's boot this baby up, start it up, and that looks good. I'm just going to go through and start them all right now. Just give it a moment to calm down. You won't have a problem finding reading about EIGRP. That's a Cisco proprietary protocol. Okay, now where is that? Control device console. I should be able to, I think this console's into all of them, all at the same time. Let's see. Oh, router F. I want to do it the other way. Where view, edit. There's a console into all of them. I'll find it later. Tools. No. Okay, I wasted enough time. So I'm going to console into A. And go to my Word document. I'm going to scroll back up to router A. Here's my notes. There's router A. Config T down to end. Control C, Alt Tab, and paste. It always hangs up here just a minute while that IP address DHCP on the outside interface is catching an address and booting up. And there we go. From here, I should be able to ping right outside, right? We're not wasting any time. Going right directly to our big test, 80%, and the rest of them will probably get 100% after this. So, router B, console in. Let's see if I did my work right. Config T down to end. Control C, Alt Tab, and paste. There we go. So I'm going to do a show IP route. And see, now we got a different, we got D's here, right? And those are our EIGRP networks. So, and there's our default route was propagated, so let's test it out. Ping 8.8.8.8. Google's probably wondering what the heck are they doing over there, right? I doubt it. Okay, router B, so we're going to go over and get router G while we're at it. I'll just do these dog legs as I move along. There's router G. Let's see. Yep, and that's the way I did it in my configuration scheme. Control C, Alt Tab, and paste. I'm using the right mouse click to paste those in. There we go, and we're going to do a show, whoops, whoa, show IP route. And again, we've already got our route propagated in there, so we should be able to ping 8.8.8.8. Bingo. And again, doing a good enough planning with our routing configurations eliminates a lot of headache and hassle. And a little bit of reading before I did this, right? G, we're down to C. I want to get rid of this. There we go, from config T down to end. Copy, Alt Tab, and paste. There we go. Let's do a show IP route. These are propagating really fast. Remember how long it took us? A little while before our routes propagated this. They didn't propagate this fast with using RIP. There we go. I should be able to, what was another command I had? Show IP protocols. And it shows that I've got EIGRP in there. It's redistributing this process ID. So only EIGRPs with this process ID are being propagated. And it shows a couple of large subnets and other routing networks. There's a couple of our small networks, right? So let's ping out, ping 8.8.8.8, and it made it out. So apparently we've configured the, let's see, which one are we on? 170. So apparently we've configured that properly, or we wouldn't get out now. And router C, there must be a dog leg off from that. So let's console into him, and I say him. In my culture, computers are animate objects, so periodically you'll hear me refer to them as him or her. Let's scroll down to, what router was that? F, yep. No shut. Added that in. I'm going to do a show IP route right away. See how, whoops. Got to spell it right. There it is. Yep, I've got a, I should be able to ping over there into the 130 already, right? And the 140. Let's see, I'm going to ping first right out. 8.8.8.8. Sure enough, that's good. I'm going to ping 192.168. Let's look over here. We're pinging out this direction to the 130.10 then, right? .10 and 100%. So I should be able to actually go over to, what was this other subnet over there? G. So let's go over to G, and I should be able to ping into the what address? 140.10, right? 192.168.140.10 and 100%. That's cool. So I get over to the other corner of the triangle here. Console in. I should be getting a bigger show IP route on this one, right? As I add more subnets. So let's go down to router D. Config T down to end. Copy that in. Paste it. There we go. Show IP route. Wow, look at that. And let's do it again as we yep, each time it's going to add a couple of routes until it gets them all in there. So I should be able to ping out 8.8.8.8. Yep, and I should be able to ping either one of those other two corner subnets, or those dog legs I call them. 192.168.130.10, and we're going to do 140.10. There we go. And from either one of those dog legs we should be able to ping back in, right? Let's see, I've got router E left. I've got to do the last dog leg. So let's go over here to router E, console in, and pick up this, copy, and paste that in. What were the other commands up there? I want to show, let's get all the way up here. Oh, either one of these. I'm going to show this one first. Copy, Alt Tab, router E, And that's only got one adjacency. Let's go over to router. Well, before I do that, I want to show my topology, right? So show EIGRP topology. What it's doing is showing all of the networks that are being distributed to me in this process ID, and it's showing what interface I can attach to them with. It's going to be kind of boring on router E. Let's go up to, let's say, router B. We should see a lot difference in router B with, I'm going to do neighbors first. So there's my neighbors. And then I want to do topology. So through each one of those different neighbors, I can reach my various subnets, right? More. Huh? That's a little more interesting. It takes a while to get used to the routing protocols. It's no different than any other thing you've done first. Like I said, they call it an autonomous system number, and it's actually a process ID or a group ID. Don't think of it as an autonomous system number, because when you look out on the internet for autonomous system numbers, you're gonna find the routers that are using autonomous system numbers to contact each other and make sure that the entire internet is updated. Probably with BGP. There we go. So I think we've done everything we needed to do, except for maybe break something. So let's go over here. I wanna have this ready real fast. I know that if I did a trace route, I'm gonna find my way out. The fastest way out is going to be through this way, right? To 8.8.8.8. Let me see if I can set this up so I can do them real fast. So I'm going to set up a ping 8.8.8.8. Let me see if there's another command out here. Repeat. So let's see, I think 100. Whoops, I've got to put in repeat, right? There we go. Then I'm going to break this. Oh, something happened. And now we're going to see how long it takes for EIGRP to reconnect. There it is. Not very long. So it only lost a few pings and then it found a new path out. EIGRP. Pretty cool, huh? Thanks for coming.